Welcome to qnawire.
Okay, so the passenger train's position, which I'll denote x sub p, can be modeled by its initial velocity, which is 25 meters per second, times time, minus 1/2 times its acceleration times squared. The freight train's position function is simply 200 meters, as it has a 200-meter head start, plus 15, that's its constant velocity, times time. If we want to find if they're going to run into each other, we need to see if there's a time in which they intersect. So we set, or that they crash or collide. So we set the passenger train's position equal to the freight train's position. And in doing this and rearranging, we get a quadratic that looks like 0.05 times t squared is equal to, sorry, not is equal to, but plus 10t minus 200 is equal to 0. Solving for t using the quadratic formula, get t is equal to 22.5 seconds. And actually, we're going to get two roots in this. The other time is something like 177 seconds, but you just take the first one because that's when they first collide. So yes, they do collide after 22.5 seconds. But we want to find where the collision takes place. So let's plug this time back into either of the position equations. So for example, we could take the freight train's position, the 200, the 200-meter head start plus 15 times 22.5 is 538 meters. So 538 meters from the front of the passenger train is when they collide. Now for part C, we want to sketch the positions of the front of the passenger train and the back of the freight train. So great. Here's our time. Here's our position axis, the origin. Now I'm going to draw the passenger train first, which is going to be decreasing, or an opening downward parabola. It starts at 0, because at t equals 0, x sub p is 0. Like something like this. And I'll draw the freight train's position with red. Now that's just going to be a straight line, because the highest power in its function is just t to the first. And it starts at 200, so let's say it starts right here, and it's just a linear line sloping upward. And we see right here is where it first intersects. Let me redraw this, it should be a little bit straighter. Oops. They first intersect here at t is equal to 22.5 seconds, or at x is equal to 538 meters.